this Yggdrasil user forum is to look at the CDF data model and IMF types, and Per Olav will lead us through some issues there, and then after that Jan will fill in with IMF type instantiation in CDF.
I think Per Olav and the team is covering both areas.
Both areas.
Yes.
Very good. Then I'll leave it to you, Per Olav, and you can lead us.
Yes. So we've been working on trying to find the flow from PCA data registers. If I just quickly share my screen, what we're after is to get the data from the POSC-CSAR information model framework data, where we have these types then described with the attributes that they may have and the blocks that they may have that again will have their own attributes, and then to be dealing with the fact that these are either in product aspect, plant aspect, and so on, so the attributes are then different for the different phases. So this is our place to go. We can query this also by using the service. So that's a combination of then using the retrieving of specific information, or then we can also write some generic or specific queries that we might need for certain things. But I'll move this over to Bård, who will be showing how we then retrieve the data using... Sure. Yes, go ahead, Bård.
Thanks, Olav. Right, so what we are using for this data ingest is, let's just see, I'll have to move that sharing layover. Can you see my screen now?
Yes, we see it.
We see it. Okay. So what we use is Neat, which is a software for ingesting, basically turning data into knowledge graphs and then again transforming it into a model that could be posted to CDF. So basically we turn the data from PCA into a CDF compliant model. And that is what we're going to do now, before I will again hand over back to Per Olav. So what we have on top of Neat, that is a tool now that is in rapid development. So they've kind of removed the old user interface and said, work directly against the code. And for that, the development team basically say that try to use this Jupyter Notebook, which is a tool, as again, on top of the Neat code, where you can actually just run pieces of the code so that you get the same functionality. So what I will do now is basically set up a Neat session. That is my first step. That will start a session on my computer. So I'll just run that, and it will read some configurations and stuff like that, and get back and say that hopefully this is okay. The next step is for me to get that IMF block that Per Olav just showed. I can go in back to the PCA library and see temperature transmitter, sure, almost. And find the same thing that Per Olav found. We have this product specification here, for instance. This is now what I will retrieve and turn into a CDF compliant model. And the step for that is basically to do an API call. And this will now retrieve that block and turn it into a turtle file on my machine. So this is the reason why we were working with files here, is because that is how Neat was set up initially. It kind of uses workflows with different steps so that you should be able to save your work between the steps. So now we have this, this turtle file on my machine. I don't think I need to show that, but we will go on to the next step, which is basically load this into Neat itself. And when we have loaded this into Neat, then is when we can start doing these transformations to turn this model we find from PCA into something that we could put into CDF. So the first thing we have to do is to ensure that we are complying with the requirements, the CDF requirements for IDs. They cannot, for instance, start with a number. So we have to do some tweaking there. And Neat has functionality for that. So now we will just run this step. And then the next thing is to verify the semantic model, that actually the things that we're trying to enter is connected, and that it makes sense. So we have a verification step. And we see here that in this verification step, we get a couple of warnings. We can inspect those. And these four, we have some classes that we perhaps should have identified a bit better or modeled a bit more. But this is just warnings. It's nothing critical, so we can continue. Now we convert these information rules that we have, because that is what this is now when we've just read the data directly from a source, and it can be a lot of different sources that Neat aligns to. And now we will convert that into a DMS model, which is a data model schema. Is that what it stands for? It is at least a format that CDF handles. So now we turn it into a DMS model. Let's see. And the rules are converted. And then finally, in this case, we will write the result to a spreadsheet that we can investigate. And why do we write this to a spreadsheet? Well, basically because in this case now, we have the one step that now is only partially automated, is that we would like to map the identifier we get from PCA to the identifiers we have in the domain model of Aker Solutions. Right, and when that is automatically mapped, we could have pushed these IMF types directly to CDF. So let me just bring up that product Excel spreadsheet that we just created. All right, let's see here. And here we find all the different properties that we had in IMF or in PCA. And we also have mapping containers that will take us from this model and into the domain model of Aker Solutions. And when those things are in place, then we can start populating it with data. So I'll hand it over to you, Per Olav, and you will show the mapping and how we populate with data.
So now you have downloaded a template from PostCaesar.
Correct.
Yes. The IMF type. This is now the IMF type description. This will create containers. Let's see here. We have these containers that are different IMF types from PCA, and we have the views accordingly. Yeah. Let's see. Yes.
Okay, I'll take over the sharing.
Thank you.
So with this sheet, we need to do mapping, and we have a master mapping table that tells us that for each one of these types, we have then codes in the container property that we need in terms of different source models. So it may either then be these codes that are for COMOS, or it may be these that are from EQHub. Or there may be some others that we have just commented either we haven't mapped them yet, or they're not applicable to NORSOC, so we didn't care about them, and so on. So we need to bring this information into the Excel sheet. So if I go in here, we can see that this Excel sheet, I've done a few tweaks on this because we want to use a reference model. And I have also decided to combine the plant and product aspect of this. I've also chosen to add a prefix for it because since the PCA names are the same, temperature transmitter, whether it's plant or product, it's a little bit hard to see in the user interfaces when everything is named the same. So that's why I did that. But now we can see that I have imported the raw table of all the mapping here and basically then apply this in here so that I can say that this property here maps in a certain way. So for instance, the parent tag here will then map to a source model with tag information and a specific property there. In the same way, if I go to the product parts, I can see that a certain property, let's pick one here. That is the IP grade from EQHub is mapped to a specific EQHub property. So with this sheet, we continue the work that is about bringing it into Jupyter. So I have this file now uploaded here, and then using Neat in the same way, I can then run Neat, and I don't think I need to do it, but basically you have starting it, you connect it to CDF, and then you get a session going, and then you download this file, which is then the Excel file, as I just showed. We can verify the process, and it gives some warnings. I can inspect those warnings, but none of them will prevent me from making the model. And then I run it to send this to CDF as a data model. And it then creates the actual data model with the necessary view types, which is what we view, and the storage type if it needs to. So here I can see the result of what it created. So we can see that it has now created all these types. So from there I can go into and look at, let me just move this. I can go in and look at my data model. And I can see now that it has created the script that contains these models. And I can then see the data that are made here. They are immediately available from the sources because that's what the mapping does. It allows us to basically just look up the data we already got. So we don't have to populate over again. So this is now the base model. And from that, we can start looking at what we got. And I'll use our search environment to look at that. So here we have both the plant type of objects that we imported, and we have the product ones. So if you look at the plant, we can see that we have then the tag numbers and the explanation. And let me scroll that a little bit down. And we have certain data about it. And we haven't very many matched properties from the plant yet. So there's still a lot of that says that, property not mapped. But this is something that now when we have this structure, we can continue going forward. And we have then the different, so this is the temperature transmitter. We have the instrument housing that has also its data. And we have, for instance, the, let's see, sensing element. We have then the data according to their type. What we can do here now is also that we can connect over to, so if I go into a specific, I can see the properties in more details. So here I can see, all the properties that this one would have. I have also connected it to an IMF element. And by doing this, I jump over to the model that tells me what is the temperature transmitter all about in the plant aspect.
Yeah.
So I can see the details of each of the properties similar to the specification in PCA. This is to allow users to get to know these models. So what are these data meaning? And I can also then look at it and see, if I look at the aspect, I can see that this is the plant aspect. And by clicking the aspect, I can see, what other blocks or block types are in these aspects, terminals. But I can also then turn around and see, what exactly did I use this aspect for in my own asset?
Yeah.
And so combining the models of the instances and the information about what it can be. So the idea now is that if we would go to the product from EQHub, we can see then I've put some information together, but basically this is a rose mount temperature transmitter, and it has a certain part number. And if we scroll to the right, we can see the data, accuracy and zero adjustment max and minimum and rated power and so on from EQHub. And then we can go into either one of these and look at them in the details and then see, all the properties that are available for that one. And also here we can look at, this is now the temperature transmitter in the product aspect. Once again, we can go over and see exactly, what are the attributes expected for this one.
So then you are back to the plant area.
Yeah,
Plant
so this is the PCA model. And then going here, these are all the EQHub candidates for this one. And then, I would need to hold that against, so these are product temperature transmitters, and we would then hold it against the plant temperature transmitters. Although we haven't put together any functionality of doing that mapping yet. But this is how then we can continue to fill in these types one by one and, add it to our model so that we can then make the plant versus product candidate comparison.
Yeah.
So in my model here, I could go, I have then, the 5 different aspects that we have. We have the attribute qualifiers. So I could go in here and see, what properties uses the qualifier of maximum. I could go in and look at all the blocks that is defined. So here I could go to, and of course here I could do search century, for instance, to get that. And if I go into that, we can also then see all the attributes that is used for this, which is actually 244. So the idea of combining the actual tag data and product data with this insight model is that people will have to slowly adapt and learn from this.
Yeah.
When this is available, we can also import this directly into Power BI and other places where people would then be looking to have something in their user environment that they are used to, if that's necessary.
Mm.
So that's another way of using these data. But this shows how they can be readily available. But the important thing is to actually then have the domain engineers do the, I had a search on, so I didn't find any results. To do the mapping so that we have more of these properties mapped instead of saying that, they're not yet mapped.
Yeah.
We have a question or a comment from Jan Edvin here. Maybe we should take that.
Yeah, go ahead.
A couple of questions, Per-Olav. First of all, the plant aspect here, we should probably use that to enrich our current class library, I guess.
Yes, and these are mapped now against your corresponding SHIFOs. So in the data model, each one of these blocks, and I think actually if I go to this one, I think it says, if I go to the detail, it will probably say that it is of a, the specific element. So these are then mapped basically towards either an RDS class or a SHIFOs class.
Yeah.
So this one has a functional class of this one. And
but again, I guess this might be richer in terms of attributes. Yeah. That's my assumption here. Next question is, okay, we have the product aspect there, and of course on the product aspect, we don't have a class library. We could, because that doesn't exist any class library yet on SHIFOs on the product product side. So, but we have to do something. We're building this Yggdrasil twin, and we need to have something there. So our plan was to start off with the current one, which is the EQ Hub, which is maybe the closest to anything for us, and then maybe use this as it mature to enrich that model as well, or that class library as well.
Yeah.
Do you think that is a good idea? Or do you recommend some other approach to this?
No, I think so. The idea here is that the PCA would hold it, and they would categorize them, as a thing of a hopefully in the future it would be an IDO reference that we all agree on.
Yeah.
And by that, the different IDO types will then be used to categorize it. The good thing about having it in this way is that I can basically, with what Bård showed and what I showed, we can create the types that we need for a task in 10 minutes. And basically, instead of being then storing all the information that already is in PCA, we can basically then go to EQ Hub, pull those that are of a type, match them with the PCA form of the data, and then start your reasoning process from that. And this can be automated and happen within the framework of, that is pleasing to users.
We have Brandon as well, has his hand up.
I think Roland, you've probably been answering my question anyway. Where do we build the master mapping across all of the different standards? And you're basically saying that that'll be hosted by PCA.
It should be, yes.
Yeah, and I guess ideally some way that we can load relationships that already exist.
Yes.
Yeah, so we can kind of lift that level.
Yeah, so in PCA, each one of these types have a classifier property which defines, what it is most like for the time being. But it should have multiple classifiers. And what we said is that, give us Shifos first if it exists, give us RDS second if that exists, or give us CDD third if that exists. But ideally, of course, we want all of those and more.
Yeah.
Yeah.
Very good. Interesting. But there is quite a bit of intervention, manual intervention for you to be able to do this. So
it's really only because neat function for retrieving it is not finished yet, which board is busy at hand trying to then change. So already he's doing more with the step that he showed than what we did actually 2 days ago.
Yeah.
So it will be more and more automation, and this mapping, if we have that mapping available in PCA, we can just pull that, with some query like this. So in this case, I actually pulled out, give me all the classifiers for the different types that I'm interested in. There you can see the different classifiers for the different types. So we could get all the mapping data out of PCA and then have the neat step consume that as a resource so that I wouldn't have to do any of that manual step. So the Jupyter Notebook is just a place where you can do step-by-step coding by hand instead of having some function doing it for you.
Yeah.
But you can change that to be, something that runs in an application.
As we speak, guys, how many classes in numbers have now been?
You have 263.
263 classes.
Yeah. So they are divided between, plants and products, and some are installed as well. So not all of these are within the same aspect. So I think that there's probably about 120 different types of things that has then multiple aspects.
And the work. Yeah, go on.
Go ahead.
Yeah, the work for us is this mappings to make sure that we have the COMOS data into the plant aspect, and we have the EQ hub mapping to the PCA IMF types.
Yeah. But correct me if I'm wrong now, Brendan, but I think you mentioned here the other day that EQ hub has done the mapping.
Brandon left
on the top level, on the class level.
Yeah, on the class level, they have a Shifos reference, but not on the property levels.
Of course not. No. But when you said 120 classes, approximately, and if you should put your finger in the air and say on Hugin Ion, how big percentages of the tags that we have in Hugin A will be covered by this?
Well, we did an investigation in the beginning of Yggdrasil where we took all the projects and we saw how many classes are normally used. And it's not that many, actually. So I think we can cover a big volume by, say, less than 500 classes.
And to that, like the IMF types that PCA have today, they are created by Draga, but the services that PCA provide allows all member organizations to suggest their own IMF types.
Absolutely.
And those types will be available as submitted once you have submitted them, and then they will go through a review process. But this is kind of trying to provide some dynamics to the standardization process that you can add your own content and use it, and then it's approved by the industry afterwards. But you can still use it, even though if it's rejected, you can still use it for your project as long as the participants there are in agreement on that.
Agreement.
There's one more thing, that in Aker BP we have a siloed activity in the more like the procurement department in our supply chain department. We have a product called MMDQ, and we have some people working on that to actually structure. This is all about avoiding to buy stuff on free text. So for every new piece of product equipment that comes into Aker BP, even spare parts, that it will have a SAP material number.
I see.
And through MMDQ, it is classified, and you have a lot of attributes there. And of course, by putting all these attributes, so what they're actually doing, they read typically data sheets, and they produce these based on a range of templates, one for pressure transmitter, one for this and one for that. But it's not synced to any of the work that we are doing here. It's completely in isolation.
Exactly.
But there is a huge work being done there over years of classifying thousands of different type of equipment. How we should be able to kind of utilize some of that stuff.
I think so, and we should collect it and bring it together into the PCA library, Jan Edvin, and make sure that we are together, build and grow this standard that we can rely upon and make interoperability work.
Exactly.
Yeah.
Exactly.
Yeah, I think the hard part is bringing this together, because we know there's a lot out there. But PCA is a common place to send it, because then we can all consume from it.
Exactly.
Didn't you back in NDG1, Jan Kåre, you did some work with a portal where you got a lot of stuff from suppliers, IX.
We are using that in the project now in Yggdrasil for all the assets, and we are collecting a lot of data from our vendors, but with reference back also to the EQ Hub.
Okay, but is that also is there a class library there? Is it the structure? Is there something we can utilize here?
No, they are using what the vendor has in general, more than pointing at a class library.
Okay, so there's a mapping exercise there as well then.
Yes, yeah, and that is because we are getting it into COMOS, and COMOS needs to be mapped to the plant aspect as POSC-CSER defines it. But we have come a long way there, since we already have done that to SHIFOS. And you see the list here of SHIFOS references. So filling the IMF types, since we have the SHIFOS reference and mapping, then we can do a lot in short time.
Also see that these are actually plant aspect temperature transmitter data records that already has identified the idea of which EQ Hub product they want to put in place here. So connecting these and then making sure that you can collate, and that's why I put these data kind of in the same place, because then you can go back and we can actually then filter on this, and I can see let's see if we get any hits on the So the temperature transmitter here now, I can see which one they are trying to buy for that. And I can now go into the details and see what details I got for that. So here you already can connect the data between then certain intent.
This is exactly what we need to get into the twin. We want this into the operational twin in Yggdrasil.
Yes.
That's why we have the plant aspect or the functional aspect and the product and individual aspects as inside the twin. And we need this to be able to fulfill our twin.
Yeah, and we are following the IMF concept, and both Equinor and you guys in Aker BP are looking for very, very similar solution. This exact same solution.
So if we can utilize this, but because we base everything upon our class library defined in Aviva ISM, okay? Which is I think we should be able to represent everything we have here, hopefully in IMF into there, because then we can auto-generate everything we need to set up our CDF data model, because we have made a parser for that. So how can we piggyback on everything if you guys that Draga and we together have developed there on the disk, and made sure that we can, without the huge load of work, utilize it and build our twin based upon it.
I think if we work on with the information model and the domain model, I think you can inherit a lot of this, Jan Øyvind, and hopefully more or less directly use it in your environment. Of course, you have some other systems, you have some other tools that you need also to map it to, but since you have the class library, you have the GFOS codes, you will get a long way with that.
You're quiet, Brendan. You need to do some work.
I think Brian have left the meeting. He had to leave.
Okay. Well, then we put a lot of work to Brendan.
Yes. Give him all the actions.
Yeah. But I agree with Brendan. This is great work, great progress, and I think we are on something here that it could be really useful.
Yeah, and even though you saw a lot of manual steps, those they are gone within some few weeks.
Yeah,
right.
No pressure, but that's it.
But then we have nobody to blame.
All I want for Christmas, right?
Exactly.
Yeah. But even though we clicked through that Jupyter notebook, that is runnable code. So that's not a problem to run in one go.
I didn't do it, but in essence, if I actually started doing it, it is this quickly.
Yeah.
So
it's done in few seconds.
Yeah. So the file had an error now, so now I had to go back. So, but so it's really That's why I say it takes 10 minutes of this in manual work. If you put it in functions, it will be probably a responsive system to having a new set of types available in CDF within a couple of minutes for a user. That would be, now I've looked at temperature transmitters, now I need to look at centrifugal pumps.
Yeah.
And really that would take you a couple of minutes to get then that new population up.
But Per Olav, what we're trying to do here is, of course, is to get this in as templates inside CDF, so we can start populating with all the data we get from Jan Kåre and the other guys in Able and so on.
And that is the domain model that we have.
And that's why I've created, let's see, slideshow from the beginning. So I just created this to show, how the core data model holds certain things. And then we have the meta model showing what IMF types and properties are all about. And then you have your asset data model, which is a model generated from these data, but it builds on the core. It connects back to this one so that your asset instance space then you saw I use the asset class and link over to explain what is it that you have in front of you, but I'm still reusing the storage. So if you would then rely on the core data model in Cognite, all of your data is going back here. So all, for instance, the name and descriptions in the search space, they're all stored in the core data container, so that CDF can reuse it across all its user interfaces and applications.
Good.
So this structure is part of the idea of how we're building this as reusable components. So this meta model of types and attributes is maintained all on its own. So that's what I call the IMF standard. While this one is then the instance spaces, where I bring in both EQ Hub and Commos data, but you could also separate those and maintain those differently. So you would have one that was, all just products, and then another one, and then you can build a solution model where I want to compare pumps, and you build a solution model for that. Another one is I want to compare instruments, then I build a solution model for that.
And that is views into your data.
Yeah, that's just mapping it so that you have a selection.
Jan Kåre, one question to you. Will you, as a service to us in the Hugin A and B project, provide the product aspect as a set of equipment that we can just transfer across to us?
Yes, I think so, if you need that, but you will still have the reference back to EQ Hub for the product aspect.
Our experience so far is in Hugin A and B. We are very, very low on the percentages that we have been utilizing EQ Hub.
Yeah, okay. But we are planning to download the product aspect when we know the function code and the function of the equipment.
Yeah. And you see what I've done in this model by combining them is that this product aspect information, can also be linked to, I didn't show that, but they could also have then the tag number, procurement package, EcoHub ID, and so on, discipline codes, and so on. So as soon as you match this product aspect with a tag, you can add those data, and then it would appear together with the tag information.
This is exactly our specification against ACE, for instance. We want them to present it, and we even want them to present, if you have a pair, you have the requirements on the function, and then the product provided with something. We want to see that side by side to verify if we have spare capacity or stuff like that.
Exactly, and here you can get the model helping you with that.
So these structures support that.
Yes.
Cool. Can't wait. We just have to get it into work. But maybe we can start with some stuff here that you have finished. Well, how is the work progressing now? We've got 120, and then according to you, Jan, we have 400 to go.
Yeah, something like that.
Who is doing what?
We are working constantly to fill that gap and
We still have Draga on the project.
It's Draga. They need to deliver, of course, into PCA, and we probably need to define some new ones as well. So it's a combination, Jan Øyvind.
Okay.
I think so getting the mapping committees going is the next step up, because even now when we have the properties, to actually fill them with the right data from the different sources is the next difficult thing.
Should we? I can get you, I guess. I have to ask for permission, but I guess that's fine. At least you, Ferdinand, can get everything we got here in MMDQ. All the work they have been on is sorting stuff out. It would be nice to share it with you, Per Olav, and some other guys, and see if we can do some AI on it and utilize it in one way.
Yeah, I had AI on the tip of my tongue as well. Yes. Because there are always patterns in that type of
the
collected
big patterns.
information.
They haven't used any ideas, but they've used names, which could be interpreted in one way or the other. So I think there are a lot of good work in there, but as long as we can't map it, we can't get the information out.
Yep.
We know we have tons of information there, which is actually LCI, but it is not released for us because we can't map it.
Okay.
But I guess we can pick up on that at the later stage and define what we can do going further from this. So
it could be a task for ADA. It could be a task for disk, something like that. Yeah,
I agree. Very good. I think we're running out of time. I think we have passed quite a bit our schedule.
Yes.
That means it's interesting. That means it's interesting.
Yeah, this is good stuff. So I think we need to close it now because I have other meetings coming up.
Thank you to the presenters, guys. Thank you.
Yeah,
thank you very much.
Yeah, we didn't. Idun wasn't part of it, but she certainly also has contributed a lot.
Yes.
So thank you.
Very good.
Thank you all.
Thanks a lot.
Thank you.
Thank you.
Bye.